whisper because my family is probably sleeping. It's a bit late now. Give me a moment here and make sure the internet connection's working, the live stream's working. It's a bit late now. Okay, chat is working. Okay. So this is like, I gotta take a deep breath. This is this question. Okay. So what I was working on is look here, maximum of absolute value expression. Okay, let's look at the question. So as you can see, I already solved it. I just did it on my own off stream, and I didn't want to stream unless I had the solution. So I already solved it, figured it out, solved it. Didn't look at the solutions, just figured it out on my own. Spent a lot of time thinking about it. I spent like days thinking about this. This was a hard question for me. This was very challenging. Given two arrays of integers with equal lengths, return the maximum of array of 1 of I minus array absolute value of array of 1 of I minus array of 1 of j plus the absolute value of array of 2 of I minus array of 2 of j plus the absolute value of I of j, I minus j, where the maximum is taken over all possible I and j less than array 1 dot length. The best way for me to explain this, so they give you examples, right? So 1 and negative 1, 2 and 4, 3 and 5, 4 and 6, 13, 1 and 0, negative 2 and negative 2, negative 5, negative 1, 0 and 7, negative 7, negative 4 and 10, etc. And for each of these, right, 0, 1, 2, and 3 are the values of I and j, right, possible values of I and j. Okay. So notice I is specifically referenced in both arrays, array of I, array 1 of I, array 2 of I, and then the index of I. And then the same for j. So it could be 1 and negative 1, and 6 and 4, with I is 0 and j is 0, 1, 2, 3, right? So you notice very quickly that this question is, they're looking for, what they're looking for is basically, it's not a distance per se, but it's a sort of a type of distance. It's basically a modified distance function. And these can be looked at as points in a two-dimensional array, a two-dimensional plane, Cartesian plane, as each of these being paired up as points in the plane, and they want this distance between the largest distance between any two pairs of points. And they also have a third dimension in here, which I'll explain what I mean by that. But basically, you could try every possible pair I and j, do a quadratic time algorithm, and it would time out. It would be too slow. There's too many points to do that. So you've got to come up with something either linear or linear-arithmetic, most likely. Something sub-quadratic. That's fast enough. Okay. So what I reasoned out was consider this as not just in 2 dimensions, a Cartesian plane, but actually 3 dimensions, where this is the third dimension. So it's actually, this would be 1, negative 1, and 0 would be the point, and this would be 2, 4, and 0, and 1 is the next point, and 3, 5, and 0, 1, 2, 2, index 2, 4, 6, and index 3. So consider this actually as a 3-dimensional problem, is the way I thought about it. And what I realized was that, hey, if it was a 2-dimensional problem, there's kind of you can go left to right over the x and y coordinates and basically take a minimum and a maximum on the leftmost side as you go left to right. And basically, the way that this distance is measured, it's absolute value of the difference. And these are integers, so basically what you end up with is effectively, or even if it wasn't integers, it'd be the same thing. Basically, you could draw lines from your points, the points that are further to the right. Basically, I'm trying to figure out on the left side, the point that's furthest away in the top left and furthest away in the bottom left, right? And so I can compare those points with the new point that I'm considering, and I can say, hey, this new point I'm considering is further up, even though it's to the right a little bit, it's further up than the value is on the left, and it's so much further up that it'll actually be further away for the x points coming to the right, it'll be further away than the previous one. And so I update it. And same thing for the bottom one, the one that's furthest down, it can be updated as well. That's in 2 dimensions. That I think that's correct. I think you prove that's correct. That'll work. That'll give you linear, really n log n time because you have to go left to right. So you have to do sorting first. So it should be n log n time. Now in 3 dimensions, it gets a little more complicated. The problem that I ran into, and I couldn't really figure it out. I was like, I'm not really sure exactly. Instead of thinking, okay, I've got this point that's further away, this other point that's further away, further away in this direction, further away in that direction. Let me also consider the 3rd dimension and just factor in the z, as in it could be added or subtracted, depending on where the points are that I'm considering. That z value, which is the extra dimension, it either could be a hindrance or a benefit, depending on the measurement. And so I figured, well, why not just factor that in my when I find these 2 points, the minimum and maximum points, the furthest points away, why not just factor in, take 2 more points instead of 2 points, have 4 points, and each of those points are split into adding z and subtracting z. Because depending on where you are, you're either going to add the z or subtract the z when you take the absolute value. So I thought, yeah, that should probably cover all cases, and that should be sufficient. So that's what I went with. That's what I tried. This is a little bit clunkier than it needs to be. The solution. I also wrote a script to generate some test cases. It's a little bit clunkier than it needs to be, but it's correct. It's correct. It's slow, but it's correct. And that's just exactly what I just described. So first I sort all the x and y and z values into by the x value by creating a map and just mapping all those pairs onto each x coordinate. So now I'm moving left to right through the map. And then I just kept track of the best possible distance I saw so far, as well as those 4 variables I described: max y plus z, max y minus z, min y plus z, min y minus z. And then I just kept track of the indices at those particular, which is just the z value, those indices at those particular points are at. And then I went sorted by x coordinate, and then I just went through each vector of y and z pairs, and I performed those calculations. So here are the updates: x plus y plus z, x plus y minus z, y minus x plus z, y minus x minus z, and then there's greater than, less than, less than. This is it creates sort of like a line. The y, you do y plus x and y minus x and all of that, and y, one is min, one is max. It's basically just imagine kind of like a almost like a triangle, like one ray and another ray, where the min value, if I'm smaller than that min value is actually, I think it's the x plus y. If I'm smaller than that x plus y, right? Yeah, it's a little bit counterintuitive, but basically the y minus x actually defines the top part, and the y plus x doesn't work. No, y minus x gives me it's a little confusing. I'm trying to remember exactly how this works. If, let's see, x plus y, right? If this max y is larger, then I'm going to update. Yeah, that's a little bit counterintuitive. Y plus x plus z is it's actually this line, y plus x plus z, which it's really confusing. But you gotta think about it, and you realize that there's a formula for this line and a formula for this line, and when you're comparing 2 points, you want the furthest away on those lines. So going in this direction, it's actually it would be, I think, negative x, and this other direction is positive x. It's confusing. You could think it through though. You could think it through. I'm kind of not explaining it properly. But if you think about it for a while, you realize that that's because of the way this distance formula is described, because it's just the absolute value. It's going to be one of these lines is going to be a negative x, one of them is going to be a positive x, and one of them, if you're, anyway. So then you just take the absolute values of all of these differences using those indices, which is just the z values. So that makes it a little bit easier. And then I take the best of all those, and I don't need to print. Actually, I didn't realize I was printing. That might be why I was so slow. Eventually, I didn't think about that. Yeah, I didn't really explain that too well. It's still pretty slow with these things. Yeah. Let me come up with a faster solution. I can modify this. But yeah, that's the basic idea. It's not that easy to see, not that easy to understand, not that easy to explain. So what I can do now, I think, is also, I don't need any of this. I could just do integers, indices, and standard iota, indices plus n 0. Fairly certain I can remove all of this. I'm gonna do a comparison by the x, really the x coordinate is all I need, and sort these indices. A, B, array 1 of A is less than array 2 of B. The rest of it I don't think needs to be sorted. And then I have the same things in here. I can just do for constant. Let's do this way. Int I 0. Even do a pointer. Index is the pointer dereferenced. And then x is going to be array 1 of index. Y is going to be array 2 of index. And Z is going to be the index itself. And then I could say, I could just do all the same logic that I had here. Same thing. I think this is all the same. I think that this is all the same. Yeah. And then the rest of this can be commented out. I think I get the same answer if I do it this way. And this should be a little bit faster. Hopefully, presumably. Could try this. Runtime error. Okay. Whoops. Okay. Interesting. Maybe this needs to be filled first. I don't know. Not sure about this. What happened exactly? No, that's not why. I did something strange. I did something odd. I don't think this is the problem. What is wrong? I'm not sure. Do I need this? Maybe. That's why I don't think that's the issue, but it could be. this could be the issue. This could be wrong. I'm trying to think here. This is just like a standard pointer, right? I mean, I don't know about this. This is a little bit weird. This is maybe a bit odd. Yeah. It could just be this is the problem. I think it's that. I think I don't have that right. That's fine. I think I just do it this way too. Maybe I shouldn't use I for that. I don't know about that. Runtime error. What is going on? What is happening? Where's the runtime error occurring? I didn't test this beforehand. To just make sure this is reached. Kind of a mistake on my part. I don't know. I was thinking this should work. At least this shouldn't give me a runtime error. 170, 170. I'm not sure why this is giving me a runtime error exactly. Iota sorted. I would not expect this to give me a runtime error. What could even the runtime error be? What is going on? There's no, I don't see any array accesses. What is happening? Oh, that's why. That has something to do with it, I'm sure. Oops, that was a bad typo. That might have something to do with it. There we go. Okay, I was gonna say, it was like, I'm pretty sure this should be fine. Yeah, okay. Yeah, and this one should be fine too. This should be fine too. I was gonna say this should not be an issue. Should not be an issue. Should be a little bit faster too, doing it that way. Alright, let me submit it and see if I get it. I think it's still correct, yeah. Yeah, same idea. A lot faster, quite a bit faster. But still pretty slow. Let me submit it one more time. So yeah, that was a tough question for me. That was really challenging. I don't know what else to say about that. Not the fastest solution, but definitely it took me a really long time. It took me days to figure that out. Alright, I think I'm gonna keep the video short. Stop it here. But yeah, that was quite a thing. That was quite a thing. Yeah, still relatively slow. Okay. I can come back later and look at more solutions, but I want to keep the video shorter. So yeah, thank you for watching. I managed to figure that out. That took me a very long time. That was rough. That was really difficult for me. Okay, alright, take care. If you liked the video, give it a like and subscribe for more.